Hi everyone, welcome to this lesson wherein I'm going to tell you about the law of sines. So if we consider a triangle, you'll note that this triangle is not like the ones that we've been doing in class lately. It's not a right triangle. It's actually called an oblique triangle. Okay, so So an oblique triangle, many triangles in the world are oblique triangles. Not all triangles are right triangles. So we need to have tools and techniques so that we can solve these triangles and not just limit ourselves to right triangles. So since this isn't a right triangle, we don't have our usual tools in the toolbox. So for example, we don't have our sine, cosine, and tangent ratios. Those are all together out. Furthermore, we don't have the Pythagorean theorem, unfortunately, so that one's out too. So we need new tools if we're going to solve these kinds of triangles. So what I'm going to do now is I'm going to go through a little bit on how we might find some new tools to use. And you'll see that it is a little bit related to sine ratios. I mean, after all, it is called the law of sines. So there are sine ratios in here. They just don't come out exactly the way that we've done them before. Okay, so if I look at this oblique triangle, the first thing that I'm going to do is I'm going to label this oblique triangle. And to do that, I'm going to start with the smallest angle, which I reckon is this one on the left, and I will call that, angle A. Then the next largest, the next largest angle I will call B, and I reckon that's this one over here. And then the largest one I will call C. So in other words, A is the smallest angle, then B, and then finally the largest one is C. Okay, so now that we have our angles sorted out, I actually want to label the side lengths as well. And so the way it works for an oblique triangle is that the side opposite the angle takes on the same name. So that this side over here is side A. Its opposite, angle A. So here's angle A, you go across, here's side A. Side B is this one, and side C is this one. So you'll notice that since angle C is the largest side, side C is the longest side. And side A is the smallest angle, angle A is the smallest angle, side A is the shortest side, and B is the one in the middle. Okay, with that out of the way, I'm now going to draw an altitude. So I'll draw the altitude from C just because it's the one that kind of makes the most sense with my diagram. So there's my altitude. And if you remember, an altitude is one wherein I construct it so that it's at 90 degrees perpendicular to, in this case, side C. Okay, with that altitude drawn, now I can start looking at sine ratios for my angles. Specifically, I'm going to start with A. So for A, I can write its sine ratio, sine of A, is going to be equal to the opposite side, this red side that I've drawn in. But I didn't actually give that a name yet, so I'll just call that H for height. So that's going to be H divided by the hypotenuse of this triangle that A is the reference angle of, so here we go. So the hypotenuse is B. Okay? What I'm now going to do is I'm going to solve this expression. I'm going to rearrange this expression in order to get H by itself. So what I'm going to do is I'm going to multiply both sides by B. So I have B times the sine of A equals H. You'll see why later on why I do that. Okay, I'm going to do the exact same thing now for angle B. And so for angle B, I can write that sine of angle B equals, once again, h divided by side length A. I know that by looking at this right angle triangle here. And I am then going to multiply both sides by A, so I have A times the sine of B equals h. All right, I'm almost done. Now you'll note that both of my expressions, this one and this one, are both equal to the same thing. H is isolated on the right-hand side. So that means that I can set these expressions equal to each other. This is similar to what we did earlier with comparison. So I'm going to have B sine A equals A sine B. All right? And then the last thing that I'm going to do is, so this is technically this is fine, but the way that the sine law is often cast is in terms of ratios. And so what I'm going to do here is I'm going to do that. I'm going to cast this in terms of a ratio, meaning I'm going to get my sides on one side and my sines on the other side. So what I'm going to do is I'm going to write B divided by A equals sine of B divided by sine of A. Okay? So in this case, I've strictly speaking set up a ratio whereby my sides are on one side and my sines, sine of the angles, are on the other side. And the way that I've done this, the way that I like to do it is I always like to write the larger number in the numerator. So if we follow what I've done already, whereby B is larger than A, then this would explicitly mean that side B is larger than side A. So this would be fine. Okay, so this is the law of sines right here. You may see it written in other ways, in other sources, but for this course, this is how I'm going to present it. Now, looking back at the original diagram, you can see that I created my altitude starting at the angles at vertex C, right? I drew my altitude starting from there, but I could have just as easily drawn an altitude starting from A and then gone across like this or something, in which case I would have found a relationship between C and B. So really, this relationship holds regardless of which two sides and which two angles you're looking for. The only thing that matters is that if you have, for example, B in the numerator, you have to have angle B in the numerator on the other side as well. All right, let's look at a couple of examples. So here I've made another oblique triangle, and in this case I have 4 pieces of information, and although there isn't a prompt, the idea is that I should find the other 2 pieces of information so as to solve the triangle. Okay, my first step would be to label the angles in the triangle here. So this angle I think is the smallest, so I'll call this A. This one is the one in the middle, so this would be B, and then C would be the largest angle. Now I know that you probably realized already that you can find the angle C just by taking 180 degrees and then subtracting the angles we already know. But let's just assume for the moment that we know how to do that, and we're going to find that using the sine law. But first what we're going to do is we're going to take a look at this diagram and notice which of the 3 sides we have, or which of the 3 side angle pairs we have. A side angle pair is a pair where you know the angle and the side, right? That's why it's called a side angle or an angle side pair. So in this case I know angle A and side length A, and I'm actually going to put a little thingy around those here to show that I have that pair. That's good. I need that. Otherwise, I can't properly set up my ratios. Okay, then I can look and see what I need, and you can see from here I'm missing side length B. That would have been written there, and I'm also missing angle C. So let's just start off by, first of all, trying to work out what side length B is. So that's where I'm gonna start. I'm gonna start by trying to find side length B. Okay. So what I'm gonna do, first of all, I'm just gonna push that over a bit, give myself a little more room. Okay. So the first thing that I'm going to do is I'm going to note that since angle B is the larger of the two angles, right, it's 55 degrees, A is only 40, since this one is the larger angle, side length B is also larger. So I'm going to write down my ratio. Again, I prefer to write the larger number in the numerator. B divided by A equals sine B divided by sine A. Okay, so that's my ratio. Again, sides go on one side, angles go on the other side. Then I'm going to substitute in all of the numbers that I know. So in this case, I don't know B, that's what I'm trying to find. I know that A is 10. I know that angle B is 55. And I know that angle A is 40 degrees. All right. So now at this point, what I should really do is I should figure out what my ratio is here. So for that I'll need a calculator, and I'm going to take, in my calculator, I'll take the sine of 55 degrees and divide it by the sine of 40 degrees. Just give me a sec while I do that. Okay, and so in my calculator I got 1.27, that's not good, 1.2744. I want to write enough places so that hopefully my answer isn't, I don't use too much of a rounding error in my answer. The left side is still B divided by 10. And so then if I want to get B, I have to multiply both sides by 10. So B equals 1.2744 times 10. And B is approximately 12.7 units. Okay? Alright. So that's how I can use my ratio to find side length. Having done that, now it would be good if I could use the same triangle and work out a missing side, missing angle rather. In this case, angle C. Now, once again, I know that you have enough information that you can just subtract these angles A and B from 180 and you're done. But let's pretend that I didn't have the information, that I didn't have angle B. So, in other words, I'm stuck using the sine law. Here's how I would do it. Okay, again, I'm just going to zoom out a little bit. And I'm going to start off by, again, writing my ratio. Since it involves C and A, I'm going to take side C, which is the longer of the two, divided by side A. And that's got to be equal to the sine of angle C divided by the sine of angle A. So that's my starting ratio. Everything looks good. I'm going to put in my numbers. 15.5 divided by 10 equals sine of C divided by sine of 40 degrees. All right. On the left side, I will do that calculation in my calculator, and I get 1.55. equals sine C divided by sine 40 degrees. Okay, now in order to get sine of C by itself, I have to multiply both sides by this term in the denominator. Now that I can just get from my calculator. So I'm going to work out the sine of 40 and then multiply both sides by the sine of 40. To show that step explicitly, I'm going to take sine of 40 degrees and multiply it by 1.55. And that will equal sine C. Alright, get out my calculator, and I find that the left-hand side is 0.9963, and that will equal the sine of C. And so now I have to undo this sine function here, and for that I will use the inverse sine button on my calculator. And if I do that, I get that angle C is about 85 degrees. Okay. Going back and looking at the triangle, given that I could have worked that out if I knew A and B. I could have worked that out from just 180 degrees minus these two guys. But it's just good to know that I would get the same answer as what came out of the sine law, in this case, 85 degrees. Okay, so folks, that's how you can use the sine law to calculate a missing side, which is what I did over here, or a missing angle, which is what I did over here. And in both cases, you can see that I set up a ratio. And the way I like to do it is I like to make the larger number be in the denominator and the smaller number be in the denominator. And it's really important that whatever is in the numerator, for example, the same thing has to be in the numerator on the other side. Okay, so in this case, C was here in the numerator, C is in the numerator, A in the denominator, A in the denominator. Okay, that's really, really important. That's about it. I hope to see you in class where we can practice a lot more of the sine law. See you then.